A batsman scores 100 runs in his last match and increases his average from 40 to 41. Find the total number of matches that he has played. So a batsman scores 100 runs in his last match. So in his last match alone he made 100 runs. So let us assume that initially he has played n matches and on an average he scored 40 runs. His average was 40. So 40n is the total that he made in the first n matches. That is, we have the basic formula: average is equal to sum of all the numbers divided by number of numbers. So this is a basic formula. So sum of all the numbers will be number of numbers into their average. That is, initially he has played n matches and its average was 40. So n numbers into 40. So this will be the total sum. So 40n is the total sum that he made in the first n matches. Then he made 100 runs in his last match. That is the n plus first match. So this is the total runs by number of innings is now n plus 1. And this average has now become 41. Earlier it was 40, now it has become 41 after scoring 100 runs in his last match, that is the n plus first match. So we need to find the total number of matches that he has played, that is equal to n plus 1. So let us solve this equation. I'll bring n plus 1 to this side, so 41n plus 41. I'll bring 40n to this side, so n is equal to 100 minus 41, so that will be 59. So initially he has played n matches and in the n plus first match he made 100. So total number of matches that he has played is n plus 1, that will be 59 plus 1, that is 60. So altogether he has played 60 matches. Hence option D is the right answer. A jar contains a mixture of two liquids A and B in the ratio 3:4. So I'll just represent it here. You have two liquids A and B. They are in the ratio 3:4. So you can take it as 3x and 4x. So you can form the equation as 3x plus 4x total is equal to 7x. Which means that if you take 7x of the mixture, it will contain 3x of A and 4x of B. That ratio will always be maintained. So if you take exactly 7 liters, that will contain 3 liters of A and 4 liters of B. This ratio will always be maintained. For example, if you take out 70 liters, that will contain 30 liters of A and 40 liters of B. If you double it, if you take out 14 liters, here the quantities of A and B will also double. A will become 6 and B will become 8, so that 6 plus 8 is 14. If you again double it to 28, B will double to 16, A will double to 12. So 12 plus 16 total is 28. Now what is said is that out of this 28 liters of the mixture was taken out. So 28 liters will contain 12 liters of A and 16 liters of B. This was removed. Now let us assume that the initial total quantity was 7x. If you consider the total quantity to be 7x, A will be 3x and B will be 4x. And 28 liters have been removed. 7 will contain 3 of A and 4 of B. In the same ratio, 28 will contain 12 of A and 16 of B. So 28 liters is removed. So effectively 12 liters of A is removed and 16 liters of B is removed. And 10 liters of A was added. Now 10 liters of A has been added. So let us find out the final quantity of A. Final quantity of A will be 3x minus 12 plus 10. So that is minus 12 plus 10, effectively minus 2. So A will be 3x minus 2. So initial quantity of A is 3x and after the change, effectively A has become 3x minus 2. So there is a 2 liters reduction that is given in option D. A person can row a certain distance downstream in 5 hours. So let us form the equation for that. you have the basic formula: distance by speed gives you time. This is the basic formula. A person can row a certain distance downstream. So distance, will take it as d. Now when he is going downstream, speed or effective velocity will be b plus r, where b is the speed of the boat in still water and r is the speed of the river, and the time required is 5 hours. So this is the equation for downstreaming: effective velocity b plus r, and return the same distance in 9 hours. Now when he is returning, it will be upstreaming and distance is same d. And when he is upstreaming, effective velocity b minus r, and the time required will be 9 hours. If the speed of the river is 2 kilometers per hour, so r is equal to 2. R is the speed of the river. So let us substitute r is equal to 2 here. R is 2, that is equal to 5, and d by b minus r. R is equal to 2 and the time is 9 hours. So this is the equation for upstreaming and this is the equation for downstreaming. Now find the speed in still water, that is speed of the boat in still water, that is b. So we'll eliminate d and we can calculate the value of b. So b plus 2, we'll bring it to the other side. So 5 into b plus 2, that is equal to 9 into b minus 2. We'll just solve it. So 5b plus 10 is equal to 9b minus 18. So I'll just work it out here. So I'll just bring 5b to this side. So 9b minus 5b, that is 4b. 4b is equal to negative 18 to this side. So 10 plus 18, that you will get it as 28. 4b is equal to 28, or b you will get it as 7. That is 7 kilometers per hour. That is the speed of the boat in still water. Hence option A, 7 kilometers per hour. Two trains of lengths 90 meter and 110 meters are running on parallel tracks in the same direction with speeds 25 meter per second and 20 meter per second respectively. So we'll just mark it here. So these are the two parallel tracks. So you have one train here. Now this train is 90 meters long, moving in this direction, and you have another train just ahead of this train. Now this train is longer, 110 meters long, also moving in the same direction. They are both moving in the same direction with speeds 25 meters per second and 20 meters per second. So here the speed is 25 meters per second and here the speed is 20 meters per second. Find the time required for the faster train to overtake the slower train. Now for this train to overtake this train, first this 110 has to be moved. First the length of the slower train has to be moved, then they will become equal. So first the length of the slower train 110, then they will become equal, and then its own body length 90. 110 plus 90, 200 has to be moved. Now they are both moving in the same direction. So relative velocity will be the difference of their speeds. So that will be 25 minus 20. So that will be 110 plus 90, 200 by 25 minus 25. So altogether 40 seconds. So that is the time required for this train to overtake this train. 40 seconds, option B. The daily wages of a person was decreased by 40%, and he now gets rupees 24 per day. So let us form the equation for that. We will assume that the original daily wages was rupees x, that was before the decrease, and it was decreased by 40%, which means that now he will get only 60% of the original daily wages, and what he is getting now is rupees 24. That is, if you decrease the daily wages by, let us say, 10%, then you will be getting 90% of the daily wages. Here it has been decreased by 40%, which means that he will now get only 60% of what he used to get, and 60% of the original value is now rupees 24. So what was his daily wage before the decrease? That is the original daily wage is x. Let us calculate the value of x. I'll cancel out the zeros here. 6 divides 4 times. So x you will get it as 10 into 4, rupees 40. So rupees 40 was the daily wage before the decrease, option B.